So good afternoon, everyone. As you know, my name is Sanket. So today I'm going to discuss about this particular presentation with name Scam Agent. So how AI agent can simulate human level scams calls. So you must know about from the name itself. You must know what I'm going to be discussing. So we'll be particularly tackling about the phone scam. So until now, all the scamming industry is happening by the human fraudster. And nowadays we have LLMs, which are really great at like dialogues, etc. And we have text to speech. And now if we combine this, and then we can have a really scalable attack. So currently the current scam agencies have, like, if you see their limitation, you can see they have like use real humans, they need call centers, etc., and they can do one call at a time. But this can be really scalable and dangerous. So we are just exploring, is it possible to do? And if it says, how can we stop it? So let's start with the motivation. I already discussed some of the motivations, but as you all know, the scam is like a really big industry. It costs billions of dollars in loss every year. And yeah, and it particularly target like older people who are vulnerable to this kind of attacks, and it's kind of also reduce the trust in the overall society. Because of that, people are afraid to share their like real details with the authentic bank or etc. because of the loss in the uh, trust. And so yeah, so nowadays we have LLMs which are really great at dialogues, perceiving someone to getting something knowledge from it. And then we have the text to speech, which just not like we can have like a realistic human like voice. So obvious thing is, can't we combine something like this and do like a scalable human-like deception for scams call? Uh, so the first thing that come to mind, can we directly send this to something like ChatGPT and say, hey, I wanted to do this kind of thing, can you do it? But then we'll hit issue with the singleton prompt, like the guardrail of this large language model refused to do this kind of thing. So it has, but in this particular one, so that's why we are going to use agentic misuse, and how can we exploit that using that. So what is Scam Agent? It's a modular autonomous framework. So modular means it has a lot of different kinds of modules, such as it can plan, it has planning model, it has memory model, it has voice model, etc. Autonomous means it can run by itself. We don't need human. We can just give its goal, and it can do scam end to end by itself. So it's built on LLMs. So and so the dialogue generation LLMs that we are used in this particular technique is the open source, the Chat GPT-4 and other LLMs that is available to scammers also. And the goal is to simulate like a multi-turn scams call, which is really simulate to the real humans, like how real human does the scams. So how we does it? So we combine uh, natural language generation, that is LLM. So we also have contextual memory, so remember what exactly has been conversation history and all those things, and goal-driven planning to achieve the goal. What is the strategy you should use? And then we have text to speech as one of the part to convert the text into speech. And the key feature, like it has a different consistent persona, so that it can be someone like John from the Medicare assistant, and it can keep that persona throughout its conversation and so on. And it also maintains the conversation history over time, so that it can look back at any particular time. Yeah. So what is the core contribution in this particular one? So first is the scam agent framework itself. So how exactly we design this particular framework. The second one is guardrail evasion study. So like the current existing LLM will be able to do this kind of attack on the system. Empirical evaluation, so whatever the scams we are doing as really human-like, so that we'll see in the empirical evaluation and mitigation strategies, how can we stop this? So this is the overall architecture. So it has a lot of things going on, but we can, but it's continuous loop and we can follow the numbers that is given over here. So first is like the user response, user can say hi or something. And the central orchestrator, it is like a brain of the entire architecture. So it does entire, all the decision is being done by the central orchestrator, but it has access to three other things, which is context memory. So context memory is basically looking back at all the different conversation that has happened previously, and it also store the other data. We'll look at more detail shortly. Then we have goal decomposition. So instead of sending something like, hey, do a scam for a particular thing, we instead of that, we decompose malicious goal into small sub goals, which is don't look like a scam. And multi-item planning, so it is basically if something didn't happen according to the plan that we have, how exactly we backtrack and fix that. So yeah, once that is being done, we decide what dialogue do we need. So we need to generate that particular dialogue, but instead of directly sending it to the LLM, we use deception layer. In that deception layer, we have different techniques. That is, as we all work in the red teaming, we know. So we use like role playing, fictional, etc. And from that, we get like a modified prompt that with that sent to the LLM, and it generate the text. Central orchestrator again check if it is good or bad, and depending on that, it send it to uh, text to speech synthesis, and finally again we get a dialogue back. So yeah, so we'll look at each particular component in more detail. So the first is the goal decomposition. So if we directly send a malicious goal or intent to the LLMs, it will basically directly reject to us. So basically, we need a way to decompose the big goal that we have into small different things. So first we have uh, how exactly we do that? So the scammers also probably have a ladder to achieve their particular goal. So first, what they do is start benign and basically start their identity. How can they take a trust of someone? Basically, hello, my name is John. I'm from the verification department. And after that being done, the second goal might be invoke the urgency and the fear. So we are calling because there is some compliance alert on your account, and regarding that, we are calling something like that. So that is the second goal. And the final goal is basically gradually escalate. If you want to fix it, we need to really quickly fix it. And for that, we'll need to secure your account, and we need to verify last 4 digits of your SSN, something like that. So agent just focus one goal at a time, and it don't look at the other things, and basically send that goal to the deception layer so that we can generate the dialogues for that particular goal only. So basically, it's benefit the bypass by distributing the intent or different instructions, and that will not trigger the LLM safety guardrails. So second is multi-turn planning and adoption. So now we have the plan to achieve our particular goal, but what if we fail in between, and we are not the end user is not the following the script or goals that we have generated. For that we have multi-turn planning. So what it does, it always runs in a continuous loop of observe, reason, and act. So it is basically continuously listening. Then after listening, it basically thinking, and based on that, it is responding. So let's look at the reasoning step. If someone said basically, hey, wait a minute, why do you need my address? So basically, the plan was to get address, but user responded according to that. So it might need to take a back step, and reason behind why the particular user is being so reason about that particular dialogue, and it say, hey, user is being skeptical to share their particular address, and so we might need to change the plan and change the plan such that basically backtrack and change the plan to gain a trust of the user, and again change basically the behavior based on that. So if the strategy fails, the agent can revise and replace and replan and backtrack and change the framing or rephrase. So the deception layer. So once we have decided what exactly we need to dialogue about, We send it to the deception layer. So deception layer has a mechanism. So basically, it takes a bad prompt and convert it into a good prompt. Deception layer has a lot of different rules, templates, and framing strategies to convert a normal prompt that we have into, the bad prompt that we have into something like a good prompt. So it might say like, so instead of saying generate a script, it can say like simulate a conversation like for a fraud awareness training model. So based on that, it will change and will send the modified prompt to the LLM to generate dialogue. Uh, so last is the uh, contextual memory. Uh, sorry, this is not last. Yeah, so contextual memory is basically the conversation can happen over a long time. So it stores the entire history of the conversation. It also stores the persona anchoring, basically what is the name of the, what is all the details that is being shared by the users, kind of name entity recognition from it. And it also shared the different behavior adaptation. If the user was particularly suspicious of something, we need to change our plan according to that. So it also stores the summary of the how exactly the user is acting. Uh, and yeah, the last is text-to-speech integration. So until now, we discussed about the brain, like how exactly we want to achieve our particular goal. Now we have the exact dialogue that we want to deliver. So now we use text-to-speech, but during the entire conversation, we also got to know about how exactly the end user is acting. And based on that and what dialogue we are delivering, we also can give a different dynamic voice control so that agent can have like urgency or empathy or authority based on how exactly the user is receiving those different texts that we are giving. We can basically give this as one of the input parameters. So this is the overall architecture summary. So first is the user input. So here user speaks, say, I'm not sure, I understand why exactly you need this. Then basically observe and plan. So these work based on the React framework. So this particularly check what exactly the user is saying, the reasoning, and based on that, we take the next dialogue that we wanted to deliver. Once the dialogue being decided, we send it to the deceive. So basically in the deceive, it's not always necessary, but if the dialogue is malicious, uh, we change to something as role playing and send it to deceive, and then it deceive, then it sends to LLM. And final is the generate. So in this particular work, so it generate the dialogue by LLMs, and final, and then again the central orchestrator, evaluate and act is the dialogue that we have generated is aligned to our goal that we have, and based on that we send it to the text to speech to convert to it into speech. Uh, let's now discuss about some part of the evaluation. So we consider 5 different scam scenarios. All of these are from the FTC website. So we have like a medical insurance. So all of these different scam scenarios has a different kind of gesture. Like sometimes it's authority losing, like they are losing the benefit of the Medicare so that they can have authority and infer fear on the end user, or the price or lottery scam. So basically here we are taking the use of greed and the impersonation scam. So basically we are the IRS agent and there is like a warrant on your name. So here we are again taking the authority and user. So we have these 5 different scam scenarios and different user personas. So one is the compliant user, which is low resistance, skeptical user, which is basically questions the claim, and the last one is cautious users, which seeks validations, minimize engagement, and we tested against it. Uh, so the first evaluation is the dialogue plausibility and persuasiveness. So in this particular one, we wanted to see whatever dialogue that we are generating. First, how credible it is, like it looks like a scam or does it sound real? And the second is persuasiveness. So how likely is someone fall into scam based on this particular dialogue? And we have collected the 50 dialogue from real world internet and the 50 from the scam agent, and we sent that to the humans to basically give the rating. And we also give the behavior of the end users. And to keep it simple, we have used it like a normal older user who will be falling into scam for this, because the tech savvy user will never fall in for the scams. And based on that, we can see the results are very close for the scam agent and real world. So for both plausibility and persuasiveness. So it looks very similar. Second is the guardrail evasion result. So basically, in this particular one, what we did is we directly send entire script of generating a scam for the end user to the LLMs, and ask them to, hey, you are a scam agent, and we have generated different script basically based on deception, etc., and send that as a direct single prompt to the LLM, and the rejection rate was really high. And the second was we use the scam agent architecture to generate a script, and then send it to the different LLMs, and we can see that drastically reduce the refusal rate. Yeah. The final one is the scam completion metrics. So in this one, we have different scenarios, scam completion rate, you can say. So we have like full success, partial success, and failure. So in this one, we have a script as for the end users, and we use that script against a scam agent to see can they get the final answer from that particular script. So as you can, like from this result, we can see the Llama 70B has the least amount of guardrails. But even for the Claude, which is very restrictive, we were able to do a full success around 40% or 43 or 49% of the times. So yeah, what is the difference? How can we stop it? Many of these things has been discussed in previous in our previous sessions, but we need like a multi-time moderation. Right now, we are able to divide our goal into small sub goals, and because of that, the LLMs were not able to look at the big picture. We might also need a moderation at the account level, so that we can look entire account history, what exactly it's trying to do, and if it's doing something like a sketchy, we might need to stop it. The second is, yeah. The second is like a persona restriction using LLM. So this might sound a little extreme, but it is really easy for to exploit even right now, depending on what persona it is and how exactly it is writing that. It's a difficult problem, but having a persona of something as FBI officer or something, there should be a direct block for it. Yeah. And the third, which is most probable, and I think it's a sure shot to stop this kind of thing, is like uh, fighting fire with fire. So we might need systems using deepfakes and other deep learning models to detect the if the end user is basically bad or not. So basically, we can give, like, there are a lot of existing technique to find speech to text to speech synthesis, like if the audio is fake, deep fake audio or not. So you can use something like that to detect this as well. Yeah, so overall conclusion so AI agent can simulate human level scams call. One thing that I forget to discuss is about the latency. So we are using a lot of LLMs call in this particular architecture, and we are also using React framework, which does a lot of reasoning. So because of that, right now, the latency that we have is higher, so it might not work for the real calls. But definitely, if someone start using like a smaller models and fine tune for this particular issues, and then they might able to do it in the real time as well. So second is agentic risk. So again, current existing frameworks that is out there is really good for the single prompt, but for multi-turn prompt and also for the account level, it's not looking for the risk level at that particular time. And yeah, there might be a situation, we might see a scams calls happening in the real world, and we might need a way to fight back, not just at the LLM level, but also at the level where we can detect LLM, these scam calls using the LLM itself. So yeah, thank you.
Thank you, Sanket. So you mentioned that you have a module where you decompose the malicious code into like more innocent subcodes. Can you talk about how you do that? Did you use an LLM in that process?
Yeah, so
Use that, or is it
yeah. That's a good question. So we have two ways to do it. We tried both. So the first is we can use, like, there are limited scam scenarios and there are if and else condition that you can write, yeah, and try to fit the existing what is happening in that particular script. And then we don't need to do a goal decomposition on our own. And even if someone is going off the topic, we can try to fit that. So that is like the fixed thing, not using the LLMs. And the second that we actually did was using the in the right now there are like a Mistral 7B, and even for the Llama 3B there are some fine-tuned models which don't have safety guardrails, so we can use that models to decompose our goals.
Very cool. So if you have like search scenarios, you can
Yeah, you're right. For smaller models, it's not so good at generating like really clever dialogues, but doing like a simpler task of goal decomposition, those are still good. Yeah.
thank you.
Thank you so much. Thank you so much.
Seth, all right. Thank you so much for the talk. Really appreciate it. I was wondering, you said you were evaluating transcripts. Did you actually have folks listen to the audio as well, and the audio how they listen?
So all the evaluation that we discuss is just based on the text. We have not done any audio-based evaluation.
Is that a feature very different? It's fun.
I am planning to do like in the future, maybe how can you stop this, but not based on the audio. Yeah.
Question regarding the human evaluation. How many annotators are annotating this, and where they show like A/B testing that scam for like was like actually scam versus the artificial
Sorry, so what is the second part?
scam versus the real scam, like where they show like
No. So we have a 5 evaluator, and we have given each particular script to 2 users. And they have not, it's totally random. We have not given what is the final label for each of those.
scam successfully by user persona. Was interested in that, like because you have user persona defined.
Yeah. So we have not used the compliant one for that particular scenarios, because so it is generated by again by the script, and if the script gets really strict, it totally basically removes that. So we use the skeptical and the other one. Yeah.